So thanks for coming out, guys, and thanks for inviting me along. I'm going to talk a little bit about Node.js 12-factor and CodeDeploy at Fairfax. So, what's Fairfax? We do print newspapers, lots of them, and you should buy more newspapers because, be good for me. We work in part of the department called Product Technology, so essentially we're responsible for stuff.co.nz platform. There's a little bit of other stuff on the edge, but primarily it's all about that one big experience, the stuff brand and all components that make up that. Lots of enterprise Java. It's traditional big corporate, big CMS platforms. There's going to be a ton of Java around there. But the idea behind Fairfax is we're doing more and more microservices over time, trying to get things away from these big behemoth systems into small, easy to manage, easy to iterate, and quick to MVP platforms. And we're very heavy Amazon users. So we've been, as a company overall, in Amazon since about 2012. And New Zealand's been probably 100% Amazon for about a year now, and that includes our major partner vendors as well as ourselves internally. So my name is Jethro. I'm the systems architect for New Zealand, so I'm responsible essentially for this finely tuned pile systems. So, not to promote myself, but we're very, very good at building infrastructure for big, heavy enterprise systems. We've got teams of people who look after banking platforms, stock exchange platforms, large-scale infrastructure for the world's kind of megacorps. But that's not what a microservice is. A microservice doesn't care how many decades of experience you have with a Java application, or how good you are at dealing with the ITIL process. It's a whole different game. And that's also we had a problem. We would try and run these systems. We would try and figure out how to work with development teams to actually get this stuff going. But we're not geared up for that. We're geared up for big, nasty platforms. So basically, traditional tooling doesn't necessarily work for the current situation we're in. It's nice having that release engineer, the support team, the build commander when you're doing a massive 3-month rollout, but you're not doing a 3-month Node.js rollout unless you're really doing something really, really wrong. You're going to work in a different space. So it's not that the tooling doesn't work, but it's too slow to iterate quickly in the environment that we're in. So it requires a professional, So we've got the finest operational team getting ready to try and sort this problem out. We need to allow internal teams to release fast. Obviously, look after your internal guys, it's important. But we also need to allow external teams. We've got a number of vendors we partner with. Sometimes it's a full toss it over the fence, let them sort it out. In other cases, it's actually you're going to build the software, we're going to provide the infrastructure, and then we're going to work collaboratively. And essentially, we want to give our developers as much control as possible. Now, that's hard being an operations guy because you want to control everything as possible. And the devs are up to no good and they're out there to cause trouble. Keep them in the cage, get some code out, release it in production. But actually, I don't want to release code. I've got no interest in sitting there all day long releasing code. I want the devs to do that. They're writing it, they can release it, they can have all that fun to themselves. I just want to build infrastructure. I don't want to build exciting, fast infrastructure. I want to get out of the way and let devs get on with it. So, everyone's going, oh, fuck, bro, why are you not using Docker? Docker's really cool. We're all using Docker currently. So, there's a couple of issues. Docker's not a completely free ride to us solving this problem. Yes, it does provide easier developer control and packaging of software. It's very simple for any dev to grab Docker on their machine, build an app that runs, and go, yep, let's ship this thing to production. It's all good, bro. It's easy to launch a new app. There's very, very little lead time. I don't have to say to someone, okay, you've got to wait, 3 months for a spin up a pre-prod environment with the Fairfax standard corporate build. It's just grab an image, away you go. And yes, it is cheaper to run. You can definitely save money by consolidating your small services onto the best bang for buck compute you can buy and running multiples in one place. But there's a few issues with that. So the main issue is, for us, is container patching and pipelining requires investment and time. It's not simply, okay, with Docker images, let's run them. It works fine for the first few months, but then you suddenly have to patch OpenSSL, you've got to deal with Node.js security vulnerabilities. When it's traditional infrastructure, I can say to my platforms, okay, I want the latest stable version of Node 4 rolled out, boom, system applies it, everything's in sync. Containers can do that as well, but you've got to have a build pipeline and processing and say, right, I want to rebuild all the containers, I want to roll them out to production. So there's a little bit of investment in tooling there. Again, there's also investment in tooling around scaling, process management. At the moment, I've got a platform that's heavily invested in Amazon, and I can say to my team, right, I want this application to autoscale. We've got the tools in place. We know how to do it. We've got commit hooks. We've got the automation. It's not having to reinvent anything from scratch. It's a 15-minute job rather than a 2-day job. And it's actually not cheaper to run for us at this moment in time. And the reason for that is that's our infrastructure spend. Microservices are this tiny little slice, and then we've got this massive, whopping, great CMS platform of evil. And we want to decrease that CMS platform of evil, but at the moment, it doesn't make any sense to spend a large amount of engineering time making microservices really cost-effective in containers, because the savings I get on that are minuscule compared to the savings I'll get on the big, whopping, evil enterprise platform by spending the engineering time there instead. It's not always going to be the case. 6 months later, I could be saying to you guys, hey, look at this cool container stuff we've been doing at Fairfax, it's great. But it all depends on the volume we're spending. It's not worth the money at this point in time to target that. It will change though, and it will definitely change. So, getting back to my earlier point, we want to be fast. We want to release stuff as quick as possible. Retooling infrastructure ain't fast. Saying to my team, right, we're going to all learn Kubernetes, we're going to discard the Amazon EC2 infrastructure knowledge we've done, we're going to focus on Kubernetes or ECS or some other platform. There's a whole bunch of retooling. That's generally a multi-month process in any sizable team. Tweaking or hacking your existing tooling, that's actually pretty fast. We can do it reasonably quickly. And I like fast, I'm not going to sit around doing something new, let's just get straight to it. So, what do we have lying around in the operational space? Well, we've got Amazon experience, we've got the tooling, we know how to build systems of pretty much any size, whether it's 2T2 micros or 14 M4 larges. Doesn't matter, it's all Amazon stuff, we know how to deal with that. We've got code, awesome. We've got the code in Git repos, even better, it's not CVS. And we've got CloudFormation and Puppet, which are our tools for building infrastructure from scratch. So, reasonably modern stack. So essentially we've got this. We've got a code somewhere, we've got a computer somewhere, we can build our servers all programmatically. So for those without a whole lot of Amazon experience, CloudFormation is a way of expressing any Amazon resource, almost any Amazon resource in a JSON format. And I can say to Amazon, hey, here's a JSON file. In it, you'll find instructions on how to build the servers I care about, the S3 bucket I care about, the RDS server I care about. Anything I want in the Amazon product suite, I can specify programmatically. So we have a workflow that involves using automation tools to generate that JSON output, because I'm not going to write it by hand, and then that builds all the systems. So I can say, I want a new microservice cluster, and it's going to be 2T2 micros minimum, or it could be max of 20, doesn't matter. I basically punch in two variables into a very cut down DSL, and it spits out a big pile of JSON, which I send to Amazon, and they go build the infrastructure for me. And then we've got Puppet involved for actually building our servers from stock Ubuntu all the way up to a fully running platform. So that's what current lay of land. Well, we need a CI/CD system. We had access to CodeShip, thanks to the AU mothership conveniently signing us up with a credit card that wasn't mine. It allows you to build and test with multiple platforms. So it's not just limited to Node.js. It's got support for Ruby, Java. I don't know if it's got .NET, but it's got a whole bunch of other things like Python. I think it has Golang. It supports MVM, so you can say, hey, I want you to test my code with Node version 4.01, whatever if I care about. Or you can say, actually, we are a Docker shop. We love Docker. Let's run it in a Docker container that meets our specific requirements. And the key thing about CodeShip for us is that it supports a wide number of deployment pipeline options. So as an infrastructure person, I'm not so interested in the CI part of it. That's something for the dev team to look after, and they'll write their tests and how they see fit. But CodeShip gives them a platform for doing so, and it then hooks into our deployment pipelines, which is the key part for me. So developers push their code into Git, they send it to CodeShip, CodeShip's run all the CI, and goes, hey, this code, it's all right. Where do we go from there? Well, we use Amazon's CodeDeploy as a deployment system. So it's free as in beer. If you're an Amazon customer, you don't pay anything to use it. You can also use it on-prem, and there's a slight charge behind that. It's kind of dumb. And I mean, Amazon will probably shoot me for saying this, but the product's not that great, except that it's got a killer feature, which is it will discover all the EC2 machines you're running and also hook into them when an autoscale event occurs. So if I said, hey, I want to deploy this code right now to my production environment, I'll go, okay, you've got box here and box here, right, I'll deploy to you, all good, deploy to you, all good. If a new box spins up an autoscale event based on load requests or traffic volumes, that new box spins up and goes, okay, hi guys, I'm a server, what code should I run? CodeDeploy goes, I know what you should be running. You should be running version 12. Boom, loads version 12 onto it. And that's kind of a feature. It does all the orchestration and machine discovery for you. I mean, you can write this yourself. I've done it before, and it's a nice exercise in pain, but you don't really want to do it. And that's kind of where traditional deployment approaches tend to fall down. Everyone's like, I've got these cap scripts or gulp scripts to do my thing. And it's like, yeah, how do you discover the machines? Oh, well, I've got an array of machine names. It's like, well, Right now, these are the machine names, in 5 minutes they'll be completely different. It doesn't work anymore. So you can write a whole bunch of plugins, or you can look at new tooling that allows you to get other stuff done. Essentially, it's a small agent. You drop on your server, it runs in the background, just listening to events. So suddenly we've got a process that actually kind of looks like an actual process. We've got our code in Git. We're sending it off to CodeShip. CodeShip's doing the CI and triggers the deployment. Deployment goes to CodeDeploy. CodeDeploy discovers all the EC2 boxes that exist for the application in question, and then it runs some filthy Ruby glue to actually run a bunch of commands on the server and deploy the application into a running environment. Just going back a little bit to the lower level, so I mentioned before using CloudFormation heavily. CloudFormation is building all the infrastructure. As CloudFormation builds the infrastructure, the first thing it builds is the autoscaling group. That autoscaling group then has multiple EC2 machines, which is essentially a VM in Amazon speak. And those Amazon machines run essentially a bunch of bash scripts. And those bash scripts say, hey, I'm a server, I should probably install Puppet, installs Puppet. And then Puppet does all the work in our environment to take it from a stock Ubuntu machine to a fully running production server. So the Puppet environment goes, hey, this EC2 box is being tagged with a Node.js server running foobar app, should probably roll it out. Starts installing all the node dependencies, installs all the environment configurations we want, like Nginx settings, that sort of thing. Final step is you've got a fully working box, and Puppet triggers and hands off to CodeDeploy. And at that point, our release comes in. So CodeDeploy goes, okay, new box come online. I'm going to send the artifact file, which is essentially a zip of the Node.js application, to the server. The filthy Ruby glue we wrote then essentially unpacks that artifact, because CodeDeploy doesn't do any native logic. It doesn't understand, hey, this is a Node app, so I should run npm install. It goes, here is a bunch of shit, I'm going to dump it on disk, and this is your problem now. It doesn't have any smarts in it. So we have a Ruby commit hook, a Ruby release hook that goes, okay, I've got this Node app, I need to do an npm install, it's got some smarts around caching and performance. It then generates init files in the system. So when I was starting to look at Node stuff, it was quite interesting, because I was talking to developers like, okay, how do I run this Node app? People are like, oh, I should use PM2, or I should use Node cluster, I should use supervisor D, and I'm like, well, fuck guys, figure something out. Like I want one, I'm an ops guy, I've got time for this, so I want one solution. And actually what it will do is essentially provide you a solution for restarting processes and for handling multiple workers. Well, we've got something on Linux for that, and it's called the modern init system. So unless you love sysv init and you can't get away from it, if you're using systemd or upstart, they both provide you the ability to respawn automatically when things fail. They provide you the ability to set numbers of components. So we say, okay, we've got a code on disk. Let's generate init files in systemd that actually runs our Node application. And instead of that being operational defined, we follow the Heroku-style proc files. So as a developer, you say, hey, I'd like to run a web app, and to run web app, run npm start or npm web app or whatever you like. And then we generate the init files based on what you've given us. And what we do then is we go, well, I need some credentials for the database and other systems I'm going to talk to. We take the secrets and credentials out of our secure store in Puppet, which is encrypted and locked down. We provide those credentials in the form of an env.env file in the application current working directory. And when it launches the app, it launches the app with all the environmentals we've defined. So you just have to, as a developer, you just have to write your app to go, hey, the port will be defined by the port environmental, and the DB will be defined by DB_name, whatever convention we use. We provide those credentials for you so you can hit the ground running. And that comes from 12-factor. So I mentioned 12-factor in my talk. What is it? How does it fit in? Basically, it's a bunch of design principles, 12, in fact, strangely enough. The ones we particularly care about from the infrastructure space is we use the environmentals for the configuration, because it's very, very easy for us to define that. We don't have to go, oh, well, Joe wrote this application, and Joe really loves YAML, so we have to write a YAML file generator from our internal store. Oh, but this other guy used .js files, so we'll shove it into that. You don't have to worry about any of that. You say your devs, there's a simple demarcation point. We'll provide these environmentals. How you suck them into your program is up to you. You can use .env, you can use something else. I don't care. It's not my problem. We expose the services via ports, so very Docker-esque. In our case, we actually prefer Unix sockets, just because it's a bit easier for operational teams. But it's kind of a semantic argument there. And of course, statelessness, which is important for any cloud systems that you're building. I mean, most of the stuff actually makes sense like statelessness. If you bring a stateful app in 2016, you've got to ask yourself some really hard questions. And it logs to standard out or standard error. So rather than going, right, I've reinvented a log file approach, We just go, fuck it, dump it out, and it can deal with it. And it's good because we in operations have all the tooling around handling files or log information that comes out in its systems. That's in place. And I mean, it's a testament to why log rotate exists, is that developers can't agree generally on how to log stuff. Everyone has their own implementation. So do I have to rotate it with copy truncate? Do I have to rotate it without copy truncate? Is it actually going to rotate by itself? You don't have to worry about any of that. You just shove it out. The OS or the platforms team deals with that. RTFM, there's heaps of stuff in the 12 Factor book or website. It's really worth reading. I think it actually came from the Heroku guys, but I'm not sure where it originated from. Really, really worth reading if you haven't already. You won't agree, if it's the first time you've seen it, you won't agree with everything. I first read it, I was like, environmentals, who the fuck would do that? Use config files, it's way smarter. But then you start actually building stuff like this, and you go, actually, there's a lot of reason and thought behind and using stuff that seems so arbitrarily simple. There's actually a method behind the madness. So I've got my obligatory goat. It has not been sacrificed, so we're going to let it live and see how we get on, and do a live demo. All right, so this is a horrible resolution. So this is CodeShip. I'm looking at right now at the Fairfax stuff internal or public, but team-specific blog. Let's make sure my internet connection is still working. Alrighty. So you can see here I've got a bunch of builds that have been going on for my project. And let's have a look at the most recent one I did. Yeah, it's pretty conventional stuff. Hey, it's grabbed my code from Bitbucket, done a checkout, it's prepared a basic container, a Docker container, done an MVM install. I should probably fix that because that's older than time and we're actually running on 4 in production. NPM install, and there's a bunch of tests, and it shoves it off to CodeDeploy to release to the application. What I really love about CodeShip is, this is all basic stuff. I mean, you can build this internally, you can use other tools. What really sold me on CodeShip was when I came to do a Java application the other day, and this Java app required a SQL database to perform a test suite. And I'm like, oh, how does the CI system get a SQL database? They provide you a SQL DB. It gets refreshed every time you run. So you can just say, hey, use this environmental to grab the DB settings. So if you use the same DB environmentals in CodeShip as you do on your infrastructure, when you test your app locally, you can connect to your local DB. When you push it to CodeShip, it connects to the CodeShip DB. And when you push to production, it connects to your production DB. There's no, hey, you're in a special environment, please do this differently. It just follows that convention, which is really, really cool. So anyway, so that's a CodeShip for our blog. We've got, oh god, UI is terrible on low res. How do I get out of this? Let me just try refresh.
Looks good at you.
Yeah. Right. There's a bit of an Amazon bug with the console where if you resize your screen, it kind of goes a bit crazy. So I've got one server. Not exactly an impressive fleet to demonstrate with, but there's a machine there. These machines are random; they get regenerated every day, so it's actually relatively new. And we've got a CodeDeploy project for this particular application. So, product technology blog. And the application in question is, well, it's a blog. And it does bloggy things. And to test release, I've actually created a test file on it. And what we're going to do is we're going to release code, and this image is going to change to something else, if I haven't screwed it up. So, we've got so this is my Git repo. This is actually a Ghost blog, and we just run Ghost as an npm module, and then we just reference the module from basically a placeholder JS file. So look at index.js. It's basically, hey, require Ghost, run the Ghost server. It means I can actually roll out releases of it quite easily, which is handy. And I've got a server over here. This is just a standard Linux box. What I'm going to do is I'm going to look at the deployment log on the machine, and I'm going to look at the application log that's running. So you'll notice two things. Obviously, we actually log the deployment output, but we also record the application under var log upstart. That's because it's a Ubuntu box and it's running via 1404, which is upstart based rather than systemd. And what's actually happening is NZ Product Technology blog web app 1 is the process that's running, and our tooling has generated that convention. So if I look under init, we've got, okay, that's our web app process, it's been generated programmatically. And that's generated from, under our technology blog, the prop file which says, okay, we want to run web app, and we run that by doing npm start production. Now, as a developer, you can, most of the apps are going to follow that convention. But if you say, fuck, Jethro, I love PM2, I don't care if you've got Upstart, I really want to use PM2, sweet. You can put PM2 right in there. That's fine with us. We don't mind. If you want to run a background job, like a background service that sits there doing something, you can do the same thing as well. You can define multiple entries. I mean, this is basically what Heroku does with their approach. We stole it blatantly from them. But it has its merits and it has its reason for using it. So this is in our code repo, we've also got our app spec. The app spec basically says, hey, I want the code in this repo to go to this location on disk, and it needs to be owned by this user, and then finally run an install hook. And the install hook is when we come to our nasty Ruby hacks. We basically say, hey, run this Ruby file, and that Ruby file does npm install, does the application restart, generates the init stuff, and all the kind of magic that makes the actual deployment work smoothly. So going back to my logs, so I'm going to watch all the application logs at the moment, and in my code repo, I prepared a new commit, so I'm going to push that commit, and without getting it PR'd, so don't do this at home, kids. It's really dangerous. All right, that's pushed out, and if I jump to CodeShip, we can see, right, CodeShip's picked up my much better commit, and it's gone against the deploy staging branch. One annoyance of CodeShip is it only does deployment hooks based on branch names. So you can't say always deploy the production tag to production. You have to do it based on branching, which is a little bit annoying. But hey, compared to traditional releases, I'll live with this. It's doing its thing. It's gone, run an npm install. We've got no tests on this app because, this live dangerously. I don't recommend that. Do please write tests on your apps, especially if I'm looking after them at 4 AM. So this is the magic part. It's gone, okay, we've done a test, we've packaged the app. I can do that manually from the command line. I can zip it up from the command line and shove it to CodeDeploy. But CodeShip's gone, right, based on that commit and bit bucket, fully automated, I've done the build, I've prepared the package, I've shoved it to CodeDeploy. Now we're waiting on CodeDeploy to do what needs to be done. And if I jump over to our CodeDeploy window, I can see here there's a release in progress to staging. I hate this UI. Okay, click on that. Amazon needs to get someone to look at the UIs because it's pretty painful. Now if I look at the events, I can see what's happening on the release right now. It's still quite an immature product. I mean, one of the annoyances is CodeShip can only be told whether the release succeeded or failed. It can't go, hey, the release failed, but it failed because your DB migration didn't work, and here's the log output. Well, I have to go to the server and grab the log output from there. It doesn't get fed all the way back. The theory that we have is that generally when we use the Amazon toolset, we tend to win out because most people jump on board the Amazon toolset if you're on the Amazon cloud, and then the toolset gets involved and gets integrated more and more, better and better. Our theory is jumping on CodeShip on CodeDeploy, before too long, they'll have better integration with CodeShip, you'll have logs coming back out and that sort of thing. It doesn't always pan out. There are Amazon products that kind of go a certain distance and then stick there, but other stuff evolves really, really well. So we're hopeful it iterates on from there. Worst case, if we find CodeDeploy doesn't evolve in the way we want it to in future, we'll just keep CodeShip and we'll just call our own custom deployment system that discovers boxes and releases to it. But it's very, very easy to hit the ground running with this platform and not to reinvent a whole bunch of work. Right. It's doing something. I jump to our box. Again, CodeDeploy is not perfect. It does an annoying thing at the moment where if I look at my CPU, see how my CPU is getting really hammered? Well, this isn't the world's best box, but about half of that is going towards CodeDeploy at the moment. The other half goes to Puppet, which also loves its CPU. And what CodeDeploy is doing is it does a really CPU expensive unpacked of a zip file. So there's a few glitches in the product like that. Not a big issue on our systems. We've got multiple boxes, we're doing one at a time, we've got redundant systems. It's not really an issue, it's just more of an annoyance at this point. But it has caused grief for people on very low memory, very low spec systems. They're like, hey, why is CodeDeploy using all my resources? Right, so something's just happened. It's gone, hey, I've getting code sent to me by CodeDeploy. Right now it's doing a lazy load of a node module, so we grab the node modules from the last release if they're already on disk, because why re-download them, and then do npm install to grab anything that's new since then. Saves waiting 5 minutes for a whole bunch of stuff to download. Alright, so done an npm install just there. We've done a merge of a config, so So that config file there includes all the settings we've generated from our Puppet configuration management system. So DB credentials are generally the most logical one. Sometimes there might be some API endpoints, secrets, things that vary by environment or can't safely be provided in the code itself. And it's actually taken that file on disk and merged it with the one that's included in the source code. So you can actually, as a developer, include a .env file if you want to with credentials or options, like defaults. We can just then blat ours over the top of it and provide a complete result and then feed it to the app. We generate new symlinks for the app, generate new entries for init upstart, restart the application. You can see here upstart's doing its thing, stopping, starting. Down here, the application is launching, doing a node launch, doing a whole bunch of debug stuff, got some debug mode, and hey, look, we've suddenly got Ghost blog running in production. So if I jump to our other window, and if I'm really lucky, that's just changed, right? I mean, it's just a static file in the repo. I couldn't be bothered changing the code, but that applies for essentially anything you're doing with the application. Change to JS, change your NPM dependencies, push to Git, wait a couple of minutes, it's in production. You can do a whole bunch of hooks around it. You can say, hey, when it releases to production, please message me on Slack or Photo or whatever you like. You can say, actually, before you release, can you please wait for a sign-off on this system? You can do it programmatically, you can do it manually, depending on how you want to do it. For a lot of this stuff, it's a small microservice for us. We're not doing the traditional change management process of, please get the 5 wizards with a golden key to sign off on this release. It's more, hey, you're a developer, do you sign this PR? His PR's approved, sweet, boom, release. In operations space, we just get a notification saying, hey, a release rolled out, and we're like, cool. We don't really care, right? It worked, it's fine. If it didn't work, the CI system should block it. And then if it got as far as going to a server and then broke on a server, that machine would fail. CodeDeploy would go, whoa, I'm not touching this box any further. Stop right there. That one machine failed, gets killed, replaced, and then we go to the dev and say, hey, your code didn't work, it broke. You might want to look into why that happened. So yes, it's like a different way of operating. I mean, we could do, if this gets, again, it's very small for us at the moment. We've got maybe 4 or 5 services running on this platform from internal and external. As we get bigger, we might have to set certain policies like, okay, you can only release between this time and this time automatically. Between these hours, it requires an operational team sign-off because no one likes the guy who releases at 6 o'clock on Friday afternoon. But we haven't had that problems because our team generally isn't a bunch of muppets and doesn't do silly things like that. Don't release on Fridays. So I guess that's a really, really quick live demo. I've got a bunch of links I'm going to plug. I was full screening that. So yeah, blog, our blog, CodeDeploy information itself, and also CodeShip. The pricing is quite good on it. Have a look. But there's plenty of other competitors as well. You don't have to use these little products. I mean, the main thing is getting a workflow that works well for your development team and your operational team. All of these components can be changed out for competitors. You could have GitHub, Travis, custom deployment system, Azure. It's the same exact principle. It doesn't have to be any of these particular tools. Cool. Well, I guess that's the end of a very rapid example. Happy to take any questions, abuse, usual. Again, shilling out my blog, Fairfax blog, Amazon products, and CodeShip itself. Thank you very much.